Welcome to Altair Engineering Training and Support. I am Apoor Bapat. I welcome you all in SUPRA SAE India 2016 pre-virtual online training session. So the agenda of this training session consists of 6 days. So out of those 6 days, we have covered day 1. Now today we will see day 2 topics that are 2D meshing, 2D geometry editing, static analysis on 2D meshed roll cage, including front impact, side impact, rear impact, torsional bump, rollover, and on later days we will see dynamic analysis on the roll cage, 3D meshing of knuckle, hub and brakes, suspension analysis using MBD, and computational fluid dynamics using AccuSolve. So let's start with the opening of hypermesh. So you can go to start all programs and click on hypermesh to open the hypermesh, and select the user profile as OptiStruct because we are going to use a solver OptiStruct to do the static analysis. So I will select the user profile as OptiStruct. I'll import the geometry of 2D roll cage. So this is my 2D geometry. So first of all, once I'll get the geometry, I have to delete the solids. So I will select solids and delete all the solids. I will check the model browser. I have so many components. So before starting, I will create one component as roll cage. Say create. Then I will go to tools, organize, select surfaces and destination component to roll cage. Select all the surfaces and say move. So now I will delete rest of the components and I will have only single component left with me, that is the roll cage. So I'll click return. I'll go to geometry editing, type as mixed. So this is my geometry roll cage. So first of all, I will show you how to edit the geometry for a single joint, and similarly you have to do it for rest of the joints. So I will show you one of the joint where I will do the geometry editing. In the same way you have to do it for all the joints. I will go to mask panel. From this icon I will go to mask panel, select the surfaces and say mask, reverse. So this is a 2D surface geometry. I have an outer pipe surface and inner pipe surface. So I have to create a mid surface in between that, as we have already seen in the last webinar that we do the meshing of 2D meshing on the mid surface. So I will create a mid surface here. So before creating a mid surface, I will do a little bit geometry editing. So I'll press F11 from the keyboard. Go to split surface lines, make the lines to lines. Split this surface, the inner one also, into proper circular section. Similarly the other end also. Similarly this section also. I'll say unsplit. So from here to here, again to here. Similarly this end to this end and this end. So node to line. Similarly of this pipe, the other end. Similarly So now I'll make this in shaded geometry. Delete the extended pipes. So I will again go to delete panel, press F2 from the keyboard, select the surfaces and delete the extended surfaces. As you can see, this is not trimmed properly, so I will trim it again and delete it. Similarly, this one also. So I will mask these pipes. Go to mask panel, F5, mask these pipes and delete the extended surfaces which are not required. I'll say mask, reverse. So now you can see I have a proper circular pipes here. Now the next step is I will go and create a mid surface. I'll go to geometry, mid surface, that is third column, fourth row. Select two surfaces and say extract. Similarly, these two surfaces, say extract. Here also these two surfaces, say extract, and these two surfaces, and click on extract. So now I will turn off this. So I have a geometry of mid surface. Now I will just join these two pipes. So I'll press Shift F9 from the keyboard, go to extend radio button, set extend over edge, toggle it down to by distance, enter the distance as 100, select the edges on the circular side of the pipe and just click on extend. So these will get extended as you can see here. Now I will trim these two pipes. So I will go to trim with surface or plane. With surface, select one surface, select the other surface and just click on trim. Now again I will go to delete panel and delete this surface. Then I will go to the mask panel, mask the outer surfaces and delete this overlapping inside surfaces. Now the next step is I will press F11 from the keyboard, go to unsplit panel and unsplit these unwanted lines, so which are not required on this geometry. So in this way I have joined these two pipes. So I want to connect all these pipes so that in the similar manner I will connect all these pipes so that my complete geometry is connected. You can see here I have a roll cage ready with me where all my pipes are properly connected. So before doing the meshing, I need this to be done first. So I have a mid surface and all my pipes are properly connected. So once I'll get a mid surface model which is properly connected, then the next step is to start creating the material as steel. Enter the material name as steel, type as isotropic, card image mat 1, click on create edit, enter the value of e new row, click return. Yeah. So I'll click on material, enter the material name as steel, type isotropic, card image mat 1, click on create edit, enter the value of e new and row, click return, again click return. So on the model browser you can see my material is created. Then I'll go to property, enter the property name as primary pipes, enter the type as 2D, card image P shell, material steel, click on create edit. I will enter the thickness as 0.15, 1.5 mm. Then secondary pipes, define a separate color, type 2D, card image P shell, material as steel, create edit, enter the thickness as 2.1. Then I will update the components. So roll gauge primary with primary pipes, update, and roll gauge secondary as secondary pipes, update. So if you have more than 3 different thickness pipes or more than 2, you can create or move the surface accordingly and create different components and create the material and properties accordingly. Now I will go with the meshing. So to do the 2D meshing, I'll go to 2D page, auto mesh panel, enter the element size, say 4, select all the surfaces, mixed mesh type as mixed, flow as aligned, size, keep all the parameters like element to surface component, first order, keep connectivity, and click on mesh. So once you click on mesh, click return. So my meshing is done, as you can see here, with secondary and primary members. So I will go through the elements quality. So to get into the elements quality panel, I'll click on F10, select the radio button as 2D. First check is the warpage. I will check for the warpage. So my warpage angle is coming as 173. So I want maximum as 10. So I will save these elements, click on save field, go to mask, elements, retrieve. So those elements which are failing are now highlighted. So I will click on mask and reverse. So I am able to see those elements which are having a warpage more than 10 degrees. So to solve those warpage, there are so many options, but the easiest way is to go to 2D auto mesh panel. Instead of surface, now select elements. Select all those elements. Select R tria and click on mesh. Then click on unmask. So again, if I press F10 from the keyboard, go to warpage. Now all my elements are passing. Now the next check is aspect ratio. So 18 elements are failing in aspect ratio, as you can see. So I will again click on save field, mask, elements, retrieve, mask, and reverse. Press shift F2 from the keyboard, select those elements which are failing. So you can see here these elements are failing in aspect ratio. So again, there are so many ways to solve these, but the easiest way is press shift F5, go to find attach, find the attached elements of these elements. So these are the attached elements of these elements, you can see here, and simply press F12, select all the elements, mesh type mixed, and click on mesh. Just remesh those elements. Shift F2, clear the temporary nodes which we have created right now. Press F10 from the keyboard. Go to aspect ratio. Again, 6 elements are failing. So I'll click on save failed. Mask, elements, retrieve, mask and reverse. Press Shift F2. Add. So I will increase this distance. So before increasing, I will find the attached element so that I will know if I am moving these elements or the length. So how much it is affecting the other elements. So I will make it to 4, or you can say 3.5. Similarly here also, I can just lower down the distance and increase this distance. So F5, mask this. Similarly here also F4, F5, mask these elements. Once this is done, you always should mask these elements so that no other elements you will have the confusion. So you can see here, if I find the attached elements, so I have a remesh option here. So F5, mask, F2 and clear these elements. Similarly here, there is a very small element you can see here. So these issues come because of the geometry. So I will just simply mask these elements and delete this. So there is a gap which I have created, so I will just simply fill this gap. So again I will go to F10, click on aspect ratio, so all my elements are passing in aspect ratio. Then the next check is Jacobian, all my elements are passing in Jacobian. Minimum angle tria, I am having some elements which are less than 10 degrees, so I don't want that. I want a minimum element, minimum angle on the tria element should be 10 degrees. So I will click on save failed, mask, elements, retrieve, mask, reverse. So shift F2, add the elements, F5, find the attached elements. So you can see there are few elements which are failing in minimum angle. So simply I will first try with the remeshing. So I'll mesh, try to remesh those, unmask all, shift F2, clear. So F10, minimum angle tria. So only one element which is having 9.94, so it is acceptable. Maximum angle tria 157 is okay. Minimum angle quad 6.51, I will check with for that. So I'll save failed, F5, elements, retrieve, mask and reverse. So shift F2, these elements you can see here are having a very less quad elements, quad angle. So I will just first try with the remesh, mesh, return, unmask all, shift F2, clear the nodes which I have created, F10, minimum angle quad, everyone is more than that. and some of the elements are failing. So you can see most of the elements here are failing. So I'll go to F12. Select these elements. F12 and mesh, return. So F10, so now I have a good quality mesh now. So I'll start applying the loading conditions. So I will first create front impact force, no card image, create. Side impact force, rear impact force, torsional force, bump force. Similarly, I will create front impact SPC, side impact SPC, rear impact SPC, torsional SPC, and bump SPC. So I'll start applying them. So I will first make this as the current, make current, analysis, forces. So for front impact, I will constrain these front members. So you can constrain complete front members also. So go to nodes, save. So you will have the total number of nodes. So that is 8353. So if I want to apply a 10,000 Newton force, so I will divide it with 8353. So I will have per node volume. So I will say minus this number and say create. So now I have the forces on this points. Now I will have front impact SPC, analysis, constraints. So I will pick the suspension mounting points to apply the constraints. DOF 1, 2, 3, create. Similarly, rear suspension mounting points. Four, five, six, create. So the first case is done. Similarly, I will create the rest of the cases. So this side impact, I will make this current. Go to forces. Apply a force on side member. So again node save. So I have a total this number of nodes. So again 10,000 divided by 3797. So copy and paste in y-axis, say create, and apply the side impact constraints. So analysis constraints, and say create. So I will turn this off, go to react, rear impact, make this as the current, apply the force on rear side, nodes save. So now I have 6248, so 10,000 divided by 6248 in x direction. So I will say create, make rear as the current, analysis constraints. So the suspension mounting points here, similarly here also. Make the torsional as current, analysis forces. So on this side, nodes save. I have 655, so I will have 10,000 divided by 655, which is 15 in z direction. Say create. Similarly, the other end, nodes save. I have 810, so 10,000 divided by 810 in minus z direction, and constrain the rear end, make current, analysis constraint, the rear end of the suspension mounting joints. Say create. Now the last one is bump, make this current, analysis forces. So I'll apply the bump load on this direction, z positive. So I have a total of 1436 nodes. So 10,000 divided by 1436 in positive z direction, and make the rear end as the constraints. Say create. Now I'll create the load steps as front impact, linear static, SPC as front impact SPC, load as front impact force, create, side impact, side impact SPC, side impact force, create. Rear impact SPC, rear impact force, create. Torsional SPC, torsional force, create. Bump SPC, bump force, create. So now I will save this file and click on analysis of OptiStruct. So it will take some time to solve. We have an error in the quality check of element 7. So we will see what was that. So I'll go to mask, element by ID, mask reverse, turn this off, shift F2, add here. So let's check the qualities of this. Aspect ratio is okay, minimum length, minimum angle, it's fine. So I'll put F4. I will just check the properties and material. So I'll go to F4 and increase this distance to somewhat and check it properly, or you can remesh it also. So save analysis of destruct. Again, one more element is failing, so I will check that element also. So mask, element by ID, mask reverse, so this is also failing. Shift F5, mask, find attach, F12 and find the attach elements. Save analysis of destruct. So we have to clear all those elements which are failing. So we have already done the quality elements check, but sometimes those element qualities are not that much appropriate. So we will have to, the solver again checks those element parameters and then it takes into the account the elements quality check. So you can see the other element is failing now. So I'll go to mask, element by ID, mask reverse, shift F5, F12, save. So generally, other people says that you can skip those element quality check, but my suggestion is you should perform all the quality elements quality checks so that the meshing which you have done has a proper elements quality, which we have discussed last time. So even if it takes time, but still I advise that go for all the elements check and make sure all the elements passes the quality criteria. So again, mask elements by ID, mask reverse, shift F5. So save, analysis, OptiStruct. So it always, whenever it gets an element error, it gives me that element number. So it checks one by one. So I am again repeating, if you have a proper geometry, the elements quality will be by default will be proper. So I'm just showing you the different ways through which you can check the elements quality and make those elements proper so that my meshing will also be proper. Mask. Go to mask. reject what F10 minimum angle, minimum angle chord, maximum angle chord. Okay, so element by ID, mask reverse, F5, F12 and rematch this portion. So mask, save this file and overwrite the analysis. Mask element by ID, mask reverse, so again it is failing, you can see here. F12, so this error mainly comes because of the geometry editing was not proper. So go to safe field, mask, elements, retrieve, reverse, mask, shift F2, shift F5, find attach, F12, mesh, return, unmask all, then F10, aspect ratio, skew, safe field, mask, elements, retrieve, mask, reverse, shift F2, add, shift F5, F12, mesh, return, unmask all, work page, aspect ratio, skew. Still few elements are failing. Then Jacobian, minimum angle quad, maximum angle quad. Shift F3, we will check the duplicates elements also. So preview equivalence. So now my elements are passed in all the elements quality check. So it has started the solver. So we'll wait for some time as it will take some time to solve. So in between, if you have any queries, you can ask me. So my analysis is completed. So I will view the results. So let's open the hyperview. So displacement for front impact, side impact, rear impact, torsional, bump with the animation, and element stresses for front impact, side impact, rear impact, torsional, and bump. So in this way, I have ended with this today's session. If you have any queries, feel free to ask us at edu-support@india.altia.com, or you can contact me also. Thank you very much for attending this session.